United Launch Alliance is using the Delta IV Medium Plus 5.4 configuration to launch WGS-7. This is the 30th Delta IV Evolved Expendable Launch Vehicle mission since the inaugural flight in 2002, and the 5th flight of the Medium Plus 5.4 configuration. The Delta IV rocket is produced in Decatur, Alabama, and is comprised of a common booster core powered by the Aerojet Rocketdyne RS-68A engine, 4 Alliant Tech Systems solid rocket motors, and a Delta cryogenic second stage powered by the Aerojet Rocketdyne RL-10B2 engine. WGS-7 is protected during ascent by a 5-meter diameter payload fairing. On June 23rd, WGS-7 was encapsulated inside its fairing, and on July 8th, the encapsulated payload fairing was transported to the Mobile Service Tower, or MST, and mated to the Delta IV. The MST is located at Space Launch Complex 37. At about 11 a.m. today, the MST was raised 8 inches and rolled back, revealing the Delta IV launch vehicle. The 33-story MST weighs about 10 million pounds and is rolled to its launch position 345 feet north of the Delta IV launch vehicle. The Delta IV stands 217 feet tall, or nearly 22 stories, and weighs about 900,000 pounds when fully fueled. The Delta IV produces more than 1.5 million pounds of thrust at liftoff. Approximately 4 minutes later, at stage separation, it weighs just 20% of what it did at liftoff. This is Delta Mission Control at T-minus 4 minutes and hold. This is Delta Mission Control at T-minus 4 minutes and holding. WGS satellites serve and protect our warfighters by providing communications for U.S. military operations on land, at sea, and in the air. WGS-7 is the first Block II follow-on satellite to be launched. It will provide worldwide flexible, high data rate, and long-haul communication for Marines, soldiers, sailors, airmen, the White House Communications Agency, the U.S. State Department, international partners, and other special users. While the team completes final preparations, let's take a look at tonight's flight.
The following profile details the important events of this mission using approximate times.
We have ignition of the RS-68 main engine. 2, 1, and we have liftoff of the Delta IV launch vehicle carrying
the Delta RS-68A main engine and 4 strap-on solid rocket motors ignite to lift the vehicle away from the pad. Shortly after liftoff, Delta begins its initial pitch and yaw maneuvers to attain the proper ascent profile and minimize aerodynamic loads. Delta IV reaches Mach 1, the speed of sound, at 33 seconds. At 45 seconds, the vehicle reaches maximum dynamic pressure. The strap-on solid rocket motors, or SRMs, burn out approximately 92 seconds into flight. At 1 minute 40 seconds, the first 2 SRMs are jettisoned. 2 seconds later, the remaining 2 solid rocket motors are jettisoned. The payload fairing is jettisoned at 3 minutes 4 seconds. Approaching booster engine cutoff, the Delta IV is burning propellant at the rate of approximately 994 pounds per second, flying at more than 118 miles in altitude and 216 miles downrange. Booster engine cutoff occurs just under 4 minutes into the flight. 6 seconds after booster engine cutoff, the first stage is jettisoned. Main engine ignition takes place at 4 minutes 15 seconds into the flight. The second stage and WGS satellite are now in the first burn, the longer of the 2 second stage engine burns. Following the second stage engine cutoff at approximately 20 minutes, the mission enters a coast phase. Just over 29 minutes into flight, the second stage main engine is reignited for the second and final burn. Following the final second stage main engine cutoff, the second stage and payload enter a coast period in preparation for spacecraft separation. At 41 minutes 59 seconds into the mission, the second stage releases the wideband global SATCOM satellite for the United States Air Force.
Master script running.
Roger.
Tonight's launch is dedicated in memory of Robert E. Morgan, Jr. Bob was a man of integrity, a principle he brought to work every day of his long career. Bob spent much of his career working in launch operations, processing Delta II vehicles for launch. He transferred to production operations in Decatur, Alabama, where he led the Delta IV engine section team before his assignment in the Transportation Ground Support Equipment Group. Bob especially enjoyed launch day and would often share his many experiences with his teammates. He left a lasting impression on every person that he touched during his career and will forever be remembered as a good man and a great coworker.
RC, verify solar radiation limits acceptable for launch.
Verified.
L-minus 10 minutes. All communications switch to channel 1. All personnel and visitors remain in present position until launch. Maintain operational silence in the LCC.
CLC performing terminal count briefing. If a condition exceeds a launch constraint any time after the terminal count status check, the observer shall announce hold, hold, hold on channel 1, identify their station, and briefly state a reason for the hold.
L-minus 9 minutes.
LC FMA.
Go ahead.
Primary wind load relief file has been loaded into RIFCA and verified with internal checksum 35 Bravo Delta.
Roger.
L-minus 8 minutes.
This is Delta Mission Control at T-minus 4 minutes and holding. We remain in the planned 15-minute hold as launch preps continue. Launch conductor Ed Kidda will pull the team in a few moments for the final go to resume the Delta IV launch countdown. 31 engineers and managers will be pulled for system status and readiness to proceed. This is the final status check before launch for all Delta vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Final processing steps just prior to launch include completing propellant topping of both vehicle stages, securing propellant tanks, and pressurizing tanks to flight pressures. Let's listen as Ed Kidda performs the final polling of the launch team.
LH2 conditioning is complete.
Roger. All steps complete prior to the status check.
L minus 7 minutes.
Status check to proceed with terminal count. MEQ.
Go.
MEA.
Go.
HYE.
Go.
LOX 1.
Go.
LOX 2.
Go.
VP.
Go.
P&E.
Go.
BP.
Go.
ATC 1.
Go.
PEA.
Go.
Fuel 1.
Go.
Fuel 2.
Go.
TM 1.
Go.
ATC 3.
Go.
TM 2.
Go.
FMA.
Go.
VE.
Go.
EEA.
Go.
GE.
Go.
SYS.
Go.
DSE.
Go.
Timer.
Go.
ECS.
Go.
QE.
Go.
USO.
Go.
OSM.
Go.
VSE.
VSE is go.
ALC.
Go.
AC.
AC is go.
RC.
Clear to proceed.
LD.
Launch vehicles ready to launch.
MD.
You have permission to launch.
Proceeding with the count.
L minus 6 minutes.
MEQ. Establish swing arm lock pins pull.
Packet.
SYS. Establish record on change list.
Polling is complete, and the launch team has given the go for launch. The countdown will resume approximately 2 minutes from now. At T-minus 4 minutes and counting, the team will enter the terminal count and will begin securing the second stage liquid oxygen tank. At T-minus 3 minutes 32 seconds, CBC liquid hydrogen and liquid oxygen tank securing is started, which includes closing the propellant, fill, and drain valves. Also at T-minus 3 minutes 32 seconds, vehicle transfer from ground facility power to its own internal battery power will be complete. At T-minus 3 minutes, the vehicle ordnance system will be armed, and the CBC liquid oxygen and liquid hydrogen propellant tanks are verified to be at flight pressure and flight level. At 2 minutes prior to liftoff, the team will verify that the hydraulic system is pressurized, as well as confirm CBC, DCSS, and FTS battery voltages. At T-minus 1 minute 20 seconds, the team will begin securing the second stage liquid hydrogen tank. At T-minus 60 seconds, the eastern range readiness is verified. At T-minus 50 seconds, the DCSS liquid hydrogen tank is secured at flight level. A final launch vehicle and spacecraft status check is conducted at T-minus 25 seconds. At T-minus 15 seconds, the ROFIs, or sparklers, are ignited to burn off excess hydrogen at the base of the vehicle. Liftoff will occur at T-minus 0. After liftoff, you'll hear the voice of Steve Agid providing launch vehicle ascent data. This is Delta Mission Control at T-minus 4 minutes and holding. We anticipate picking up the launch count in just a few moments.
T-minus 4 minutes and counting.
Upper stage lock securing started. CBC propellant securing started.
Vehicle transferring internal.
3 minutes 50.
The countdown clock has resumed, and we are proceeding towards an 8:07 p.m. Eastern liftoff.
T-minus 3 minutes 32 seconds.
Vehicle transfer internal. Complete.
3:30.
Upper stage lock secure at flight level.
CBC lock secured.
CBC pre-press started.
3 minutes 7 seconds.
CBC LH2 secured.
T-minus 3 minutes.
Vehicle ordnance arming. CBC locks at flight pressure and flight level. Vehicle ordnance armed.
T-minus 2 minutes, 32 seconds and counting. Once the rocket lifts off, it will only take about 33 seconds to reach Mach 1, or the speed of sound.
T-minus 2 minutes.
TPA script running.
Hydraulic press at 4,000.
CBC LH2 at flight pressure and flight level.
T-minus 1 minute and 30 seconds and counting. The launch vehicle, payload, ground systems, and eastern range are go for launch.
T-minus 1 minute 20.
Upper stage LH2 securing started.
T-minus 1 minute 10.
T-minus 1 minute and counting.
Box go.
Rock, report range status.
This is the Rock, range green.
50 seconds. 45.
Launch enabled. GE main power off.
Main power off. Upper stage LH2 secure at flight level.
T-minus 30 seconds.
T-minus 30.
Status check.
Go Delta.
Go WGS.
25.
Green board.
Flight lock-in.
23.
SRM TVC below down.
15.
Brophy ignition.
T-minus 10, 9, 8, 7, 6, 5, 4, 3. We have ignition. 2, 1, 0, and liftoff of the United Launch Alliance Delta IV rocket carrying the 7th WGS satellite for the United States Air Force. The wideband global SATCOM satellite provides significantly increased capacity for our nation's leaders, warfighters, and international partners.
Maximum SRM chamber pressure now. Coming up 30 seconds. 34 seconds, Mach 1, vehicle now going transonic. Passing 40 seconds, altitude 3.7 nautical miles. 45 seconds, maximum dynamic pressure, max Q on the vehicle. 50 seconds in. Altitude 6.38 nautical miles, velocity 2,532 feet per second, downrange distance 4.43 nautical miles. 1 minute into the flight.
You are hearing the voice of Steve Agate providing launch vehicle ascent data.
Miles, velocity 3,646 feet per second, downrange distance 7.44 nautical miles. Standing by for a solid rocket motor burnout, about 10 seconds from now. And we have burnout, standing by for SEP. And we have separation. 4 solid rocket motors have separated. 1 minute, 50 seconds in. Delta vehicle now weighs half of what it weighed at launch, expelling propellant at the rate of 1,945 pounds per second. 2 minutes into the flight. Altitude now passing 35.5 nautical miles. Velocity 6,443 feet per second. Downrange distance 34 nautical miles. 2 minutes, 14 seconds in. Past Mach 5. Hydrogen supply valve on the second stage are open, allowing fuel for our second stage flight. Passing 2 minutes, 31 seconds. Two minutes, 40 seconds in. Altitude 54.7 nautical miles, velocity 8,773 feet per second, downrange distance 67 nautical miles. Bearing separation should be about 15 seconds from now. Standing by. And fairing SEP. Good fairing SEP, 3 minutes, 14 seconds in. 75.5 nautical miles in altitude, 12,000 feet per second, downrange distance 116.8 nautical miles. 3 minutes, 28 seconds in. We'll be going to the partial thrust mode about 15 seconds from now. 57% thrust level, standing by. And we've been commanded to partial thrust. Standing by for main engine cutoff. Main engine cutoff. Standing by for stage SEP. And we have stage separation. NEDS is deploying. Standing by for the igniter spark. Igniter spark, standing by for ignition. And we have ignition. Ignition on the second stage. Second stage chamber pressure is coming up. Good chamber pressure on the second stage. Good stable burn. Recovering from the initial ignition transients. 4 minutes, 41 seconds in. Altitude now passing 144 nautical miles.
This is Delta Mission Control at AL plus 4 minutes, 58 seconds. We've just heard Steve Agid report the successful execution of the early events of tonight's flight, and all systems continue to operate nominally. The Delta IV and WGS satellite are traveling southeasterly over the Atlantic Ocean, away from the Florida coast. The mission is now in the first of 2 planned RL-10 engine burns. This burn will last approximately 16 minutes. I'm joined now by Captain Doug Downs of the Air Force's Military Satellite Communications System Directorate. Captain, thanks for joining me.
Thanks, Trevor. It's an honor to be here.
So what does the WGS system provide to the warfighter?
Well, Trevor, the WGS system, which was first launched in 2007, provides the warfighter with worldwide, anytime communications. A single WGS satellite has more communications capability than the entire Discus constellation. On top of that, it also provides the ability for crossbanding, which means you can connect the X-band and Ka band for users that might be on those different bands at any time. This provides the unique ability to support the warfighter whether they're at tactical headquarters or on the move. WGS currently collects and routes real-time data through thousands of fielded terminals worldwide, supporting tactical communications. WGS satellites also support the Global Broadcast System, also known as GBS. You can think of this as being like DirecTV. It's always there, always broadcasting. You just have to tune in. Warfighters can do that to get some situational awareness. In addition to providing the essential communications for the command and control of deployed forces, WGS also provides the warfighter with a 24/7 means of communication, allowing for coordination of efforts or calling for support if required.
Okay, so for users that may not have a real good understanding of satellite communications, can you explain a little bit more about how that works?
I'd be happy to, Trevor. So it starts off with some information that needs to get from one point to another. For example, let's say a combatant commander in Afghanistan needs to get some support from Allied forces on an aircraft carrier in the Indian Ocean. So in the past, the way you had to do this, way back, you started with signal fires, smoke, flags, things like that. And you moved on to wires and eventually terrestrial radio. But all of these methods have some drawback. Either speed, it takes a long time to get that message over, or you have line of sight issues. If you don't have a direct link, a mountain's in the way, won't be able to make that communication. So to solve this problem, you can put a satellite above the Earth at about 22,200 miles. So at this distance, you see about a third of the Earth's surface. From that position, your satellite, in this case WGS, can send and receive communications almost instantaneously, 24/7. And in our case, the battalion commander would be able to use an antenna within that field of view of the satellite, that 1/3 of the Earth's surface, send the communication to the satellite, it'll collect it, route it, send it back down to the Allied forces on the aircraft carrier. It doesn't matter how far apart they are or what is in the way, that communication will get through.
Wow, fantastic. That's some impressive stuff. Can you tell us a little bit about the WGS-7 satellite itself?
Well, the WGS-7 satellite is rather impressive itself. So on orbit, when it's in its final position, it'll weigh around 7,600 pounds. So to put that in perspective, you're talking about the weight of a 3/4 ton pickup truck. And then once the solar arrays are fully deployed, so from tip to tip of those arrays, you're looking at 135 feet, which is even more than the aircraft that you might have flown into the Cape with, which is probably a Boeing 737 or something similar. WGS-7 will orbit the Earth in a geostationary orbit, which means the amount of time it takes for the satellite to orbit the Earth is the same amount of time it takes the Earth to revolve once about its axis, so about 24 hours. This unique orbit allows the satellite to stay directly over a given point on the equator, so you don't have to try to be adjusting to maintain communication. To make this happen, you have to have the satellite at about 22,200 miles above the Earth's surface and be traveling around 6,800 miles per hour, which is smoking. You're moving fast at that point. And over the 14-year design life of a WGS, you're going to travel 900 million miles. Wow. With WGS seeing nearly 1/3 of the Earth's surface and providing critical communications ability, it's an absolutely necessary asset.
Absolutely. So what role does the WGS program play in the Air Force's overall mission?
Well, military satellite communications, or MILSATCOM, provides a critical capability to our troops, our nation's leaders, and our allies. So the WGS program provides a piece of that. They provide the wideband portion of the communication as part of the MILSATCOM Directorate. The mission at the MILSATCOM Directorate is to acquire and maintain these communications capabilities with ever-increasing capacity and acquisition efficiency. Many military satellite communication programs are developed, managed, and sustained by the MILSATCOM Systems Directorate.
Okay. How does this mission fit into the Space and Missile Systems Center?
Well, the Space and Missile Systems Center, or SMC, is responsible for fulfilling all sorts of DoD, Department of Defense, space-related needs, to include the acquisition of space launch vehicles like the Delta IV that had carried WGS now into orbit, as well as providing for the navigation, weather, and missile warning satellites. On top of that, they do the ground systems that support those satellites, like the Air Force